In this video, we're going to talk about frequency distributions. Recall before we discussed different types of data, different types of variables. Well, now we've collected the data somehow using one of our methods of sampling. Now we need to start trying to organize it. So one way to organize it is through frequency distributions. These are ways to put things into table form using classes and frequencies. The first type that we're going to look at is categorical frequency distributions. And when we're talking about categorical frequency distributions, recall that there were two different distinct types of variables. There was the qualitative variable, the categories, or there was the quantitative variable, the numbers. Well, for categorical frequency distributions, we are looking at putting data that is qualitative, that categorical type, into some type of table distribution that we can look at. And so that's what we're going to do. So let's look at this example where we're looking at the eye color of students in a class. So students have told me that they feel their eye color falls into the category of being blue, hazel, black, green, or brown. I've asked 20 of my students, and down here are the results. As you can see, I've just put the results down as the students gave them to me. And what this information is just one student had blue, next student had black eyes, the next student had blue eyes, then I had several that had brown eyes, then I had hazel eyes. So I have collected the data. Now I need to put it into some type of way of organizing it so that eventually I can present it to someone else. Because right now it looks a little scattered. So what the first step I'm going to do is I'm going to make a table just as the one shown here. And what I'm going to do is I'm going to have a column for class, a column for tally, a column for frequency, and a column for percent. Now, the class column is just what category did each person fall under. Did they fall under the blue, the black, the brown, the hazel, or the green? So all I've done so far is put down all of my categories that I was given. Then I'm going to look for the tallies. The tally, I am literally going to come through here and say, okay, this person falls in the blue category. This person has black eyes, so they fall under the black category. Then I have another blue. Then I have 1, 2, 3, 4, 5 browns. 5 browns. Then I have a hazel, a green, another blue, another green, 2 more blacks, another hazel, another green, a brown, a black, brown, and blue. So what I have done is I have literally put a tally mark for each student based on the results that they gave me. This is going to help me for the next step when I look at frequency. Right now, again, all I've done is done the tally. Step 3 tells me to count the tallies and place those results in the frequency column. So literally all I'm going to do is I'm through here and say I've got 1, 2, 3, 4, and I'm going to write down a 4. I'm going to count how many are in the black tally, and that's 4. I have 7 in the brown, I have 2 in the hazel, and I have 3 in the green. What I did was I counted up how many tally marks I had and put that here in the frequency column. I just put the numerical number of the tallies that I had. Next step is this percent step. One thing that we need to look at is what we call the N. N is the total number of data points that you have. So if I count up total number of students that I asked for this particular segment, the total number that I asked was 20. So my N is 20 whenever I'm talking about this for this particular problem. And it's going to be very important that we remember what N is. It's going to come back into play in several other places throughout the semester, so make sure that you kind of begin to get the idea of the N. Now then, to determine the percentage, what I'm going to do is I'm going to take the frequency and I'm going to divide it by the total number, then multiply it by 100. So for example, to get the percentage of the blue, I'm going to take 4 divided by 20 and multiply it by 100. When I do this calculation, 4 divided by 20 times 100 gives me 20. I do the same thing for the black eyes. 4 divided by 20 times 100 is 20. So 20% of the students that I looked at in this group right here had blue eyes, and then 20% also had black eyes. To get the number of brown eyed students there were, I'm going to take 7 and divide it by 20, multiply it by 100, and I get 35. So 35% of the students had brown eyes. The hazel eyes, 2 divided by 20 multiplied by 100 is going to be 10%. Then the green eyes, 3 divided by 20 times 100 is going to be 15%. If you're able to do this correctly and you add up the percentages, they should add up to a total of 100%, meaning you have everybody's valued there. So this is how we would do what we call the categorical frequency distributions. Those that we use for anything with categories, any type of qualitative data. We can also use this exact same thing if we're talking about something with a small range where it's just a few items. We can use the categories, the classes, 2, 3, 4, something along those lines. We can use the same aspect there. When we get into data sets that have a large range, that's when we're going to use something called a grouped frequency distribution. What I mean by a large range is that the range is equal to the highest value minus the lowest value. And I actually do the calculation and get a single number for the range. So if my range is only 2 or 3 points, I want to do something just like what I did for the categorical. But if my range is 35, 50, even 20, and especially if it's in the hundreds, I want to use what we call a grouped frequency distribution. We are going to have lower class limits and upper class limits. Lower class limits will be the lower value for that limit, and the upper class limits are obviously the upper values of the class. Both of those will have the same number of decimal places as the data originally starts with. So if we are talking about a person's age, age is usually given in whole years. Therefore, our class limits will also be in whole years. If we're talking about weight, a lot of times that's given in 1 decimal place. So our class limits might be in 1 decimal place. Whatever your data has as far as number of decimal places, that is what your class limits will also have. Class boundaries are a little bit different than class limits. They're the upper and lower values whose values have 1 additional decimal place more than the data, and they end in the digit of 5. So let's say that you had a class that had a limit of 4, started at 4 and ended at 9. So this is your lower limit, and the 9 is your upper class limit. But when we start talking about class boundaries, how we find the class boundaries is we take our lower limit and we subtract 1/2 from it. And so my class boundary would actually be 3.5. To get the upper class boundary, I take my upper limit, but I add 0.5. So I've got 9.5. So I'm going a little bit below this number and a little bit above this number. So I've got on half a space below and half a space above to get my class boundaries. On the lower limit, I'm always going to go lower, so I'm going to subtract 0.5. On the upper limit, I'm always going to go up, so I'm going to add 0.5. And we will see how this is done in a few moments where we get into an example as well. The class width has to do with the difference between each of the classes. It's not necessarily the difference between the class limit, lower and upper, like the 4 to 9. It's actually between the lower limits or the upper limits. So if we look at the example I just gave, I had a class limit of 4 to 9. So that meant that my next limit would start at 10. And the reason I know that is because whatever this class ends at, the next class must start at. And we'll get into some of those rules here in a moment as well. But my class width is the difference between these two numbers, my lower limits. So 10 minus 4 is 6. So that would be my class width for this particular example that I'm looking at. Class midpoint uses this x sub m notation, and we're going to have a lot of different notation again, like I said, with the n, and now we have x sub m, which means midpoint. And you're really going to need to know what each of the variables and each of the notations mean, so you might want to even get a notebook or a sheet of paper and start writing down each of the different variables as we go along. But the class midpoint is calculated by averaging the upper and lower limits. So what I'm going to do is I'm going to take the midpoint is equal to the lower limit plus the upper limit divided by 2. So I'm averaging those two, upper plus lower divided by 2, and that will give me my midpoint. Okay, the rules for the classes in a grouped frequency distribution. What I mean by the classes, again, was that 4 to 9, the 10 to whatever. Those are different classes. There should be between 5 and 20 classes. If you get smaller than 5 classes, you really just need to do individual classes. They shouldn't be grouped at that point. If you get larger than 20, your data and everything looks way too much, very overwhelming, so you really need to keep things manageable, and that's between 5 and 20 classes. In here, most of the time you will be given the number of classes for each of your problems. In the real world, you kind of pick the number of classes you want, and a lot of times it depends on how large is your data set, what's that range. The larger the range, the more classes you really want to look at. The class width should be an odd number. So when we're finding the class width, we're going to round up, and this is going to be key. We always want to round up to the next odd number. So if I get a class width that is 4.3, I'm going to round that up to 5 because that's my next odd number. But if I get a class width that is 5.3, I'm actually going to round that up to 7 because that is my next odd number. If I round it up to my next whole number, that would be 6. But since 6 is even, I want to go one higher. We want our class width to be odd, and we're always going to round up. This is one of the places in statistics that we definitely change our rounding rules. Class width is always rounded up. If we don't round up, then we don't have the upper limit that will include our largest data value, and that is extremely important in these cases. Okay, the classes must be mutually exclusive, which means one number cannot go in more than one class. So if I look at some examples, let's see here, let me try writing that again for us. Let's look at age. And if I have the class limits 10 to 20, 20 to 30, 30 to 40, okay, I have a problem. Because if someone is exactly 20 years old, do they go in this class or do they go in this class? What it means to be mutually exclusive is they should only be in one or the other classes. So this is actually incorrect. They should not overlap like this. Okay? Now let's look at if I have age over here and I go 10 to 20, 21 to 31, 32 to 42. Now notice that if someone is 20, they only go in this class. If someone is 21, they come to the very next class, which is going to bring me to my next rule for grouped frequency distributions, is they must be mutually exclusive, they cannot overlap, but they also must be continuous. Is that there should be, wherever this one ends, the next one should start immediately. So this one ended at 31, this one needs to start at 32. Since this one ends at 42, the next one should start at 43. Okay? So this one is going to be our correct way of looking at things. This just reiterates that there should be between 5 and 20 classes. The class width should be an odd number. Classes should be mutually exclusive. And just like I was saying a moment ago, they should be continuous, meaning there should be a class for everyone. Even if I go back in and add some numbers to my data set, I should be able to add anything between that's within my range and get it into one of the classes. Classes must be exhaustive. What this means is that all my classes, I should have enough there that it contains anything from my lowest number to my highest number in my data set. There should not be a single data point that is left out of any of my classes. And then the class width must be equal, or the classes must be equal in width. I'm going to use the same class width all the way through my problem. This says except in open-ended distributions. We're not going to worry about that for our particular purposes. Open-ended distributions are where they ask for if anybody is under the age of 15 or over the age of 82. They give you categories such as that, or classes that we can look at such as that. We're not going to look at items like that in this case. Okay, steps for constructing a grouped frequency distribution. The first step is to determine the number of classes. When I determine the number of classes, the first thing I want to do is I want to find the highest and the lowest values. So whatever the highest and the lowest values are in my data set. Once I do that, I'm going to find the range, and remember that the range is the highest number minus the lowest number. So that's equal to the highest minus the lowest. Okay. Then I'm going to select the number of classes. Which most of the time this is given to us. And then I'm going to find my class width. Here's how we're going to find class width. Class width is equal to our highest minus our lowest, which recall was our range, divided by the number of classes that we're using. So we're going to look at our highest value minus our lowest value divided by the number of classes. and this will give us our class width, and this will be the class width that we use throughout the entire problem. Remember that we're going to round this number up to the next odd number, whatever that might be. So let's look at just an example of how to find the class width. If I have some numbers and my highest number is 135, my lowest number is 15, and I want 6 classes. Okay, so what I'm going to do is, in order to find my class width, that's going to be 135 minus 15 divided by 6. So 135 minus 15 gives me 120 divided by 6, which is going to be 20. Even though this is a whole number, remember I want it to be odd, so I'm going to use a class width of 21 because I always want to round up to the next odd number. Now this was just an example of showing you kind of how we would solve if we knew what our highest number, our lowest number, and our number of classes we wanted was, which most of the time you will. Okay, after we have found our class width, we need to select a starting point. We're always going to use the lowest value that we have. Okay. Then we're going to add the class width to get the lower limits. So for instance, in the problem or the example I just gave you, we had the lowest number was 15, and my class width that I was going to use was 21. So I start with the 15 being my lowest limit, lower limit, and then I'm going to add 21 down, and I'll get 36. From there I can again add 21 down, and I get 57. These are all lower limits that I'm looking at. And I do that until I get 6 lower limits because I wanted 6 classes to begin with. Once I have the lower limits, I want to find my upper limits. Now recall that our limits must be continuous. Therefore, if this one starts at 36, the previous one must have ended at 35. That means this one goes from 15 to 35, the next one starts at 36. Therefore, it's continuous. Once I have my first upper limit, what I'm going to do is I'm again going to come over here and add 21 to my 35, and I'll get 56, and I'll add 21 again, and I'll get 77. And I can do this all the way down until I get all 6 of my classes. Once I have my class limits, I'm going to come in here and do my class boundaries, which, if you'll recall, was taking half off of this one and adding half to this one. So my class boundaries would actually be 14.5 to 35.5. Then, looking at my next class, it would be 35.5 to 56.5. Then 56.5 to 77.5. These are my class boundaries. These are my class limits. Lower limits, upper limits. Notice that my boundaries 35.5, 35.5. They are the exact same upper limit to the next lower limit, which is the way I want it, because anything in between there, 35.55, needs to be able to go into a category. And now with these boundaries, they can do so. Okay, I've determined the classes, class limits, class boundaries. Then I'm going to tally up the data. And then I will find the numeric values for the frequencies and check on the boundaries again. Let's do an example. This example suggests that we're going to construct a grouped frequency distribution. The following data represents the stories in 30 of the world's tallest buildings. So the number of stories in 30 of the world's tallest buildings. We want to construct a grouped frequency distribution for the data using 7 classes. Okay, well, some of the things that we wanted to do was we wanted to find our highest and our lowest numbers. 54 is my lowest and 110 is my highest. Once I do that, then I can find my class width. Remember, class width is my highest minus my lowest divided by the number of classes that I'm looking at. So 110 minus 54 gives me 56 divided by 7, which gives me a perfect 8. That's an even number, so the class width that I'm going to use is going to be 9. This just reiterates that, and it reminds you to always round up, and we need to use an odd number for the class width. What I've done on this slide is I've taken and I've gotten the class limits. I started out at the lowest number, and then I added 9 down till I got 7 classes. So I've got 54, 63, 72. Then once I had the 63, I subtracted 1 and got my 62, and then added 9 down until I got all 7 classes. Here's my table. I apologize for this. It should have been moved down a little bit. But these are my class limits. These are my class boundaries. Then I'm going to look at the tallies and the frequency. Okay. The tally column you do not have to use. I don't always, sometimes I do. But all it does is help me go through my data, especially when there's larger numbers, and say, okay, the first data point goes in which group, the second one goes in which group, things of that nature. Okay, and so this is actually where I have done and gotten, here is my frequency. There were 7 and again this got shifted off a little bit, there were 7 that fell within the class of 54 to 62. There were 6 that fell within the class of 63 to 71, and so forth. And you can go back and double check if you want to look at the original data again. Check my math. Always check my math, okay? Sometimes we want to use something called a cumulative frequency table. And what I've done here is these are the class boundaries that we found. Remember, our smallest number that we had was 54. And then if we subtract half of that, it was 53.5. And then it has all of my class boundaries here. Cumulative frequency uses the frequencies given, but we look at everything less than that number. So for example, in our particular data, there was 0 numbers less than 53.5. And here's a key. You always start a cumulative frequency table at 0. The very first one is always 0. Okay. Things less than 62.5, there were 7 because they fell in the range of 54 to 62. Things less than 71.5, that was 13. Then if I add the 8 from the next line, that's going to be 21. And then there were 4 in the next line, so that's going to be 25. 1 more is going to be 26. 3 more is going to be 29. And 1 more is going to be 30. I took the frequency and I was adding it on each row. Okay. Now if you have questions about the cumulative frequency table or any of the frequency distributions, please come see me, let me know. Otherwise, go practice section 2.1 now.